This is an extra video to explain, introduce the TypeScript for you. In our project developing, sometimes we see that projects writing in TypeScript, and the TypeScript, the name is very similar to JavaScript. Are they really related? And when and why we should choose it? Let's go. First, it's about the TypeScript. The TypeScript name is similar to JavaScript. Are they really related? The answer is yes. TypeScript has a very unusual relationship to JavaScript. It offers all the JavaScript's features and an additional layer on the top of this, which is the TypeScript's typing system, which means that the TypeScript has one more feature, which is the typing system, than the JavaScript. Therefore, in a nutshell, TypeScript is the JavaScript with type. Here are some core features for the TypeScript. The first one is the type inference. As you create a variable and give a initial value to this variable, this value is bounded to the initial type you gave to this variable, and it is bounded, and it is happened by this language. It infers this type for you. The second one is you can define a type in the TypeScript. The third one is composing types. This is very similar to the enumerate in the Java language, which means you can composite different values, specific values like true or false, or even just some strings as a type. And the last one is structural type system, which means that the TypeScript uses a typing mechanism called duck typing, which means even if an object that you did not specify which type it belongs to, but if it has all the attributes of another type, so when the type checking happens, it can also be considered as that type. That's a very brief introduce about TypeScript, but when and why we should use it. Here are some advantages of the TypeScript. The first one is it can catch the errors at compile time. Since the TypeScript has the static typing, which means that you cannot switch the types, and the types are enforced to your project. You can the compiler will catch the errors at the very early stage of your development, and you do not need to wait until you try to run your project and find out the problem. So it is a good advantage. The second one is the auto-completion. Since all the types and the fields in a type you defined is already defined, so it gives so the IDEs can give you more specific suggestions to autocomplete the code that you are writing, which can improve the pace of your development, make it more easily and quicker. The second one is better readability, because everything has a type and it can provide you more information of the variables, so it has better readability. The fourth one is optional static typing. The fifth one is better for larger code base, because for TypeScript, the rules are more strict, and you can enforce more rules in TypeScript. So it is not that flexible, but more stable. So when you are developing a very large project, using TypeScript is more safe. And that's the brief introduction to TypeScript, and we can go to see what does all these things means. Here we can create a variable called title here. and we can give it an initial value of maybe hello hola mundo. So you can see that here the title has a type of string. But what if we want to change the value for it? We want to change it into 1, 2, 3. What will happen? The JavaScript will allow us to do that, but in the TypeScript, it will complain about it. This is an error because type number is not assignable to the type string because the title has been inferred as a string type. So we are not allowed to assign a number value to a string type. This is how this type inference happens. The second one is defining a type. How can we define a type in the TypeScript? First, we can use the keyword called interface. And next is the name of this type. The types, you can, for the custom types, it's better to start with the capital letter. And maybe we can define a type called student. And this student type has several fields, or you can say attributes. The first is the ID. The ID has to be a number, so you can just say it should be a number. And also, of course, a name. And it should be a string. And it can also has major. It also has to be a string, right? And here, after this, you can initialize a variable of this student. Maybe my name is Yao, so I will type Yao, and I am a student. And then I can define the values of me. I have an ID of maybe 1, 2, 3, and my name is Yao. Maybe I do not use the same name. Student 1. Okay. And has a name of Yao. It should be a string. And I have also a major of CS, which stands for the computer system. So it looks fine. It looks all right. And the student has the name, ID, major, and I can easily access the student's value by student1.id major name. So it's very easy. But what if we want to give a different thing? Like I want to give a string to this ID. What will happen? It will not allow us to do that because we define the ID has to be a number. So we cannot assign this kind of value for it. And otherwise, we can also like if we change the name into a name with the capital name, it will also complain because this kind of things, ID, name, major, it's not defined as a student because the student do not have an attribute called capital starting name. So this is not allowed. This can be very helpful. This kind of definition of types can be very helpful when we are developing web projects, because sometimes we are passing kind of huge data between the front end and the back end, and the back end between the components of the back end. If we do not have an interface and do not define the object, it is very it can be very common that we will miss some attributes, and sometimes if the name of the field is very complicated, we can easily mix up them, and we have to go back and forward to find out which attributes an object can have, and it's kind of a waste of time and also gives a lot of chances for us to make mistakes. And the third one is to composite some types. It means that we can composite some values as a new type. So this is how can we define a type. So maybe we can define a new type called major. Type major. It can have it should be it should be the different values of this type should be connected with a single OR, and the majors can be only CS align, and maybe IS, which is just the majors we offers in the Silicon Valley in the NU Corey College of Computer Science, right? And this is our new major. So this major, we can use this major as its type. So we define this type, and this major can only have these three values. So now we offer this major as the CS. But what if we want to change it into DS, data science? What will happen? It will say that, well, let's say what it will say. DS is not assignable to major because the major type can only have three values: CS, CS line, and IS. DS is not a good value, is not acceptable to this. This is very helpful because in this way we can very easily to enforce some rules to the variables, and in this way we can avoid many errors. So if we give a new definition for this and call it DS, it will then not complain about it. This is very helpful, and I think it's very good. The last one is structural type system. The structural type system means it uses the duck typing. So what can we do is try to see something like this. We first define interface, which is type. We can call it a point. This point can have two attributes: x, which is a number, and y, which is also a number. And we can define a function. Function maybe just add, point add, p add, which takes in two value variables: a point and b point. And it should a console log, maybe just return the a.x plus b.x, and maybe just console log dot log a dot x plus b dot x a dot y b dot y, something like this. And this only applies for the a and b, right? And according to what we said, the input should only be a type a and b. But what if now we have another const of c, which is a point not just in the 2D space, it is in a 3D space, which means it has a type of x1, y1, z1. Alright, and we have a const d, which is x2, y2, and we have another point called const e, which is x1, z1. What will happen? So we can use the p-add. We can apply the p-add to c and d, but we cannot apply p-add to d and e. You can see that it will not, although C does not it is not the type of point because it has 3 attributes x, y, z, but it passes this type checking because it has all the attributes of the point, so it is considered as this type. But for E, it has xz, it is not all the attributes of this point, so it will complain about this. Is not assignable to this point. So that's how this structure